Assalamualaikum warahmatullahi wabarakatuh, and good day to each and everyone. So this is EE221 and this is Sir Hanif. So last meeting we have already discussed the fundamental concept of capacitor and inductors. So right now we will proceed to evaluate their applications in sinusoidal state response and in frequency domain representation, or what we call as an impedance. Okay, so actually, for the sinusoidal state response of a certain circuits that composes of capacitor and inductors at the same time the resistance, it only goes through a function of time. Then after that, after we found out the time um, time representation of a circuit, so we can now solve its equivalent expression that signifies um, or that represent its applications or response in a certain time. Okay, so yun lang actually. So for example, this circuit here. So as you can see here, we have here the source voltage that is actually equal to V sub O cosine of omega t. So this is actually a sinusoidal source, no? Kasi it's composed of cosine. So basta cosine siya, it is actually a sinusoidal. Okay, then we also have here the resistance and we also have here the inductance. Now what we need is to find out the time representation of this circuit. So if we take a loop on this one, okay, so we have here a loop, no? If we take a loop on that one, so we can now have this equation here. So we have first na ma-encounter natin kay itong source voltage which is equals to V sub O cosine of omega t, and since we first encounter its negative sign, so ilalagay natin yun siya sa kabilang side ng equal sign. So dito yun siya, V sub O cosine of omega t. Then for the voltage across the inductor, the resistor, I mean, that would be the multiplication of the resistor in the current, no? So which is our current is I of t. So ibig sabihin yung current natin dito is a function of time also. Then for the voltage across the inductor, we have here L di over dt. So you are already familiar with this one kasi I have already discussed this representation of the voltage of the conductor. Okay, now to using a koan Euler's identity, okay, we can actually have this one, no? So since this is actually, if we take the solution of this one, this actually composes of real and imaginary part. Then for the real part, we have this one, v sub o e to the power of j omega. So we have this uh, expression, no? So okay, so ito yan siya. V sub o cosine of omega t is equals to real of this value here, no? The solution of this kabilang side. Okay? So then after that, no? After we can have this one, actually, we can now find the value for the current, no? Or the time function of that current. So we have now this one. Okay, then substitute the value for all the terms. So we can now have this one here. Okay? Then also, if we divide this one by both side by r plus j omega s, we can now have this one. Okay? And for most, we have now these final equations here. Okay? Ito yun siya. Then for the phi, expression for phi, that will be negative tangent inverse of omega L over r. Okay? So we can now have this final equation here. Okay? So this would be the real part of the solution, and this would be the imaginary part of the solution. Okay, so if we take a look on this expression here and we separate the value of real part and the imaginary part using this angle phi here, we can now have this expression of real part and imaginary part here. Okay, so we have here a procedure on how to get that one. So you may just have to follow this in order for you um, to have this to have this procedure here, to have this sinusoidal steady state response of this circuit. Okay? So pag sinabi mong sinusoidal steady state response, that would be the function, or that would be the response of a circuit as a function of time. Okay? So as what we have just done here, no, in doing this a series of solution. Okay, so you just have to follow this procedure. Now in electric circuits, um, we have the so-called um, the frequency domain representation. Frequency domain, what do you mean by that one? So we will be transferring the the parameters here, itong mga resistance na to at saka yung inductance na to. We will be, di ba, this is a function of time, so we will transform that one into a function of frequency. Okay, so by that, okay, after we transform all of these parameter here, okay, which are as a function of time into as a function of frequency, so we can now have the simplification of this circuit. Okay, so we will no longer deal with this equation here and use a differential equation to solve that one. So what we do is only to have the simplification of the circuit and substituting the value. And sometimes we call that one as a phasor representation of a circuit, okay, when dealing with frequency domain. Okay, so by that we will know about how to know, or we will know about how to determine the impedance equivalent of a certain inductance or certain capacitance. Okay, so yun. Okay, so ito yan siya, no? Okay, we have also here pala na example. Okay, so just read this one. These are just a representation of um, how to do this procedure here in time, in time representation. Okay, time independent representation. So we have also here a graph on how to physically see what happened in the circuit. Okay, also we have here one. So this graph here is particularly mm, determined by using a plot uh, by using a computer plotting instrument. Okay, so we can determine this graph here by using these equations here that we have just derived. Okay, ito yan siya. Okay, and know what happens, what exactly happening on that circuit itself. Okay, so now we have now here the phasor, no, or the what we have just introduced kanina na frequency domain. Okay, so as you can see, these are just as time domain, no. Ito yun siya. Uh, ito yung equations or representations na ginamit natin previously. Okay. Now, what we can do here to simplify this one is to represent this one into phasor. Okay. So what do you mean by phasor? So in phasor representation, what we need is only the amplitude, okay? Only the amplitude and the angle or the phasor that associated uh, with that expression, okay? So as long as the signal is sinusoidal or cosinusoidal, we can represent them into a phasor representation. So once again, in phasor, what we need is only the amplitude and the phasor that is associated with them. Okay, so we have here for this representation, we can get the amplitude A here, no? Yung amplitude natin kay A, and then yung phasor na associated with that one is yung phi. So we can now rewrite that one as this one. So what that we have here, V is equals to A e to the power of j phi. Or for more represented na or more precise na way on how to represent that one, we just have to note that one by using this one. So we have here A angle phi. Okay, so once again, as long as this is cosinusoidal or sinusoidal, we can now just use the amplitude and the phasor associated with that signal to represent that one into a phasor form. So we have now this one. Okay, so ito yung tinatawag natin na phasor form. We have the amplitude and we have the phase. Okay, so just read this one on how to utilize that one, no? Ito yun siya. We have also here. And ito siya kay, we have derived this one, okay, this equation here to know more about the phasor representation of a capacitance, no? Okay, so by doing this series of solution or um, mathematical manipulation, so we have here the original form of equation. So this is the equation of current across the capacitor. No, if you remember, that would be I of t is equals to c dv over dt. And if we simplify that once, we can now have this form of equation here. No, so as you can see here, the current daw is equal to j omega c multiplied by the voltage across the capacitor. Okay? So, therefore, no, a capacitor pala can be represented using current and the voltage, no? So, we are familiar with this representation of current in terms of voltage, right? 'Di ba? Sa Ohm's law natin, the voltage uh, as a function of current, okay, or the voltage that is proportional to the current has a proportionality constant of resistance, right? No? So, for example, no? So, can I write this? Wait lang, ha? Um, Gamitin natin to. Wait lang. So, for example, we have here, um, wait lang. So, for example, di ba, sa previous natin na, ano yun, uh, lectures, we have for the relationship of the voltage and current is we have here V is equals to current multiplied by the resistance, right? Okay. So if we compare this equation with this equation natin dito, ito yun siya. If we compare that one, we have doon kay current is equals to J omega C tapos voltage. If we compare that, if we compare this equation, okay, we can know that in this case, okay, in this equation here, solving for voltage, we have 1 over J omega C multiplied by the current. Okay. Now, in our previous representation of Ohm's law, if you have this equation, we can now say that this term here, or this expression here, is a um, an impedance, no? Impedance representation of the capacitance, right? 'Di ba kasi yung capacitance natin na C, yung C lang, it cannot be represented using voltage and current itself, no? So for us to be able to represent that one into voltage and current, we need this one. So this means that this capacitance here, or this expression here, is the impedance representation of capacitance. So therefore, uh, we can say that X, or we call that one as a reactance, no? Reactance of the capacitance is equal to 1 over omega c. Okay? So take note that for that expression, omega is equals to 2 pi, no? This is all this is um this is always equal to 2 pi multiplied by the frequency. Okay? Frequency of the signal. Okay? So yan. Take note of that. Okay? So yan. So palagi niyong tatandaan na for us to be able to solve for the expression of the capacitance involving in a circuit, we need this equivalent reactance. Okay? We need this equivalent reactance of a capacitance. Okay, so that's why in here, we from this expression of time domain, we transform that one into a frequency domain using this expression here. Okay. So now for the inductance, naman, we originate with this equation here. Then after a series of manipulation of that equation, we can now have this one here, this equation. So the same, if we, wait lang ha, um, the same if we compare that one with the kuan, voltage equal to IR, okay? So from that equation, na na-derive natin, we have the voltage is equals to J omega L multiplied by the current, no? Tingnan nga natin. Ay, tama, no? J omega L multiplied by current. Okay, so J omega L multiplied by the current. So by comparing these two equations, we can now know that the equivalent impedance or equivalent reactance of the inductor is equal to omega L, right? And take note once again, for omega is equals to 2 pi 2 pi f L. Okay? So 2 pi multiplied by the inductors. Take note of this one. Always remember that for us to be able to solve a series of combination of a resistor and capacitor inductor, we first need to represent them into a frequency domain in using this equivalent or equivalent impedance or reactance of capacitor and inductor. Okay? So, okay, so yan. Kaya ganito yung ating equation, final equation. So we have here a summary, no? If you can remember. So this is the time domain representation of the current in terms of voltage of the capacitor, voltage in terms of the current of the inductor, and voltage in terms of resistance, voltage in terms of current of the resistance. So this is the symbol, and this is the relationship in terms of frequency domain, and this is also the symbol. So these are the summary, okay? So we have now here this one, okay? So we have here an example. So kindly study this example, a series of examples here. um, these are just on how to simplify that, or how to use that representation that we have just discussed. Okay, so please study these ones. And if you have any question regarding these examples, kindly ask it to me further para hindi tayo magka-problema. So anyway, no, nandito lang naman yung summary niya. Okay, these are the summary. So please, no, if you ever to study this series of example here, kindly refer to this summary of equations. So once again, that's all. If you have any question regarding this discussion, so kindly ask it to me right away, no? So that's all. I hope you are safe. Assalamualaikum warahmatullahi wabarakatuh, and good day.